Okay, the last case study we're going to look at today is one that will show yet a different set of Java structured concurrency features. And this is going to demonstrate the structured task scope class. And it's going to do some interesting computations and do various similar kinds of things we've done before. However, this is going to stick pretty much exclusively with Java 7 features, which is a bit more in the spirit of what the structured concurrency is about. As usual, you can find the results and the example and everything in my ex3 project in the Loom folder in my live lessons GitHub repository. So now we're in the ex3 project in the Loom folder in my GitHub repository for live lessons. And let's take a look at the ex3 program. And you can see it's very much like ex2. We parse some arguments, and then we go ahead and demonstrate the structured concurrency mechanisms. This time, we're going to do things a little bit differently. We're going to have structured concurrency using the StructuredTaskScope class and its related classes, which I think is really where Java structured concurrency is heading. The new virtual thread per task executor still exists, but it's just being sort of ignored because it's not quite as powerful in some ways as the structured task scope is. So this particular example is going to make a new ShutdownOnFailure object called scope in the try with resources block portion. And once that's initialized, we go into the actual block itself. And you can see we make ourselves a new array list, which will have a list of futures to big fractions. We're then going to generate a bunch of random big fractions. And then for each random big fraction, which will be unreduced, by the way, we're going to go ahead and add them to the end of the results list one at a time by forking off new virtual threads for each of these big fractions, and then reducing and multiplying each big fraction by some constant. So this fork call on scope will make a new virtual thread that will do this computation concurrently with respect to everything else. Now, just to show you very quickly what reduce and multiply does, it's super simple. It does exactly what you think it does. It takes the big fraction that's passed as a parameter, reduces it, and then multiplies it by the other parameter. So just something to burn some CPU time, nothing particularly profound. What we're focusing on here is the fact that all these things are running concurrently in virtual threads that have been spawned in the context of this scope. And after we start everything running, we then use scope.join, which is a barrier synchronizer that will wait for all the virtual threads to finish, or for the task scope to shut down if something goes wrong, like if there's an exception. And in this case, there will not be. But we join everything. And then when we're done, we go ahead and sort and print the results. And this is a good example of what's kind of a botch with structured concurrency as it exists at the moment, because there's no structured concurrency way to do something like this clever technique, where we quick sort the list in one thread using the supply async factor method on the completable future API. And then we go ahead and heap sort the list in another background thread from the common fork join pool using a different thread to heap sort. And then we use the except either method, which is one of these completion stage methods that's so cool in completable futures that will trigger whichever one finishes first. So if quicksort finishes first, we'll take the results of quicksort. If heap sort finishes first, we'll take the results of heap sort, and then we'll print the results out. There is no way to do this with Java structured concurrency, because it only works for embarrassingly parallel processing tasks where all the processing starts, all the processing completes, we get the results, and then we take all the results. But that's not what we want to do here. We want to be able to take whichever result finishes first. And you really can't do that kind of thing with structured concurrency because it's based on Java futures, not Java completable futures, which I think is a mistake, but obviously those guys have a different mental model in mind about how to program this stuff. So just kind of showing you how this works, we can then go ahead and start everything up, and it'll generate a bunch of random unreduced big fractions, and then we go off and use the structured concurrency mechanisms. You can also notice it'll give you warnings. Warning, warning, you're using the incubator module, da-da-da-da. Just so you don't forget and think that this might stay stable because it could change. And here you can see we generated a bunch of random big fractions that were unreduced. We then reduced them and multiplied them by some big constant. And then we sorted them. You can see they're sorted and they're vast. So the application is not as interesting as the way in which we computed the results, which in this case used the new structured task scope mechanisms that are available in Java 19's structured concurrency model.